So, hello guys. Now today we are in chapter 2, and chapter 2 has to do with everything relating to computer hardware. And under this chapter, we'll be covering block diagram of the hardware system, the input device, the output device, the storage devices, central processing unit, and the application controls. So let's quickly dive into the topics, and as I'm reading them, explaining, I will appreciate if you form your notes, because after this chapter 2 we'll be doing chapter 3 in class. So today, if you look at the screen, you see the definition of what an hardware is. It says the computer hardware structure. Now you can write this. I'll tell you which aspect you should write. Now, a computer system consists of three broad components. The hardware, that's one. Number two, the software. And number three, the humanware. When you talk about the humanware, you are talking about you, the individual who is operating the application or this computer system. That's the humanware. Now, as you can see, it says the hardware is the physical unit, which is the connection of the electronic components of the computer. So you might be asked in your exam that the dash is the physical unit, which is the connection of electronic computers, components of the computer system. So you could be asked, the dash is the physical unit of the component of the computer system. Or you can be asked that the hardware is the physical unit, which is the dash of the electronic component of the computer system. So note all this. Now, the software, you can write this also. The software is the suite of programs which is processed by the hardware and allows the hardware to function effectively and efficiently. A program is a sequence of instructions written in a particular computer language, which is carried out by the hardware to solve a given problem. Now, the truth of the matter is that there's really no hardware without a software component. Now, every hardware you see in this modern world needs one form of software or instruction before it performs. Every electronic device, be it your flat screen, your smartphone, use one form of software instruction. And software itself are sets of computer programs developed by a system programmer, an individual who is a programmer. A programmer is an individual who writes computer programs. And what are computer programs? Computer programs are sets of code, instructions, which they write for your computer to run on. Now let's go to the humanware. The humanware consists of people who operate and maintain the computer system. Since no computer can function without human being, no matter how remotely controlled, humanware is omitted for now. So what they are saying is that obviously you can't have a computer without the influence of an human being. So for now, we won't be talking much about the human. We'll be diving straight into the hardware and software components. So the hardware is divided into two major components: the central processing unit which you all call the CPU, and the support devices. So the central processing unit. Now let's talk about the online and offline equipment. So now anytime you hear the word online or offline, just have it at the back of your mind that these are systems or operations. For online, any operation or information that has to do with the internet, or that has to do with the processing of information and transferring the information from one computer system over a network, that is an online, or over a communication device. And offline, the system works internally within itself. It's not transmitting the information from one computer to the other. The information stays within the computer system. So let us write. A support equipment that is currently set up so that it can transmit data or to receive output information from the CPU over a communication line is said to be online, i.e., a support equipment that is connected to the CPU, whereas a support equipment without the capability is classified as offline. So, a peripheral equipment is a support equipment that is designed primarily to be used in an online mode. Example are your communication terminals. Those are your modems or your network switches or your communication satellites. B, printer and VDU. C, keyboard. An auxiliary equipment is a support equipment that is designed to work in an offline mode. Example, one is a microfilm reader found in many libraries. 2, the data entry devices that are used in large data processing centers to enter data offline onto a tape or a disk. So let's talk about the summary of an elemental structure of the hardware. We have the input device. Basically, your input device is any device that allows you enter raw data into a computer, which will then be processed and outputted as an information. So an input device, as we can rightly say, are like your microphone, which, for instance, I'm using a microphone with this laptop. It's an input device. Your keyboard is an input device. Your memory card is an input device. All these devices enables you input information or data into your computer system. That's A. B, your central processing unit is where all the arithmetic configuration takes place in your computer system. As you can see, it says is the main unit of the hardware. It consists of internal memories, arithmetic logical units, and a control unit. It accepts data from an input device, performs instructions specified by the program, and results are sent to an output device. You can write those down. So whenever you are confused, you can pause the video, rewind, then play back again. C, output device receives the result of processing from the processor. Your storage device are your external auxiliary device, i.e. your hard drive or your disk drive. Computer input unit. Data to be stored or processed in a computer system is first converted to a form called machine readable form, In our chapter 1 we did binary operations, and those binary operations are a series of zeros and 1. Those zeros and 1 in computer are called the machine languages. The 0 stands for off, the 1 stands for on. These are the numbers your computer will convert any information or data. This is what they understand. So when you, for instance, if your name is Michael, the computer do not see Michael, but a series of algorithms, zeros of 1, that represent the word Michael. I hope I'm clear enough. You can read through the data, the diagram on the screen. This is your data entry system. It says source data, data conversion, data in machine readable, input units, data coded in internal form, memory, process, data. So you can go through this, and you can also choose to draw the data. It's not compulsory though. Direct and indirect input device. Don't let me waste too much time. I will just read what I will read is what you should just write. We won't go through the entire passage. The term direct means that data is in a form suitable for processing without the need for data conversion. Example of data input device that produces direct data input includes optical mark reader, magnetic ink character reader (MICR), and optical character reader (OCR). So, categories of input media. The input media can be categorized as follows. A, your tags or barcode. You see, when you go to a supermarket, you buy a product in a pack. Check the back or bottom of the product. You will see a series of lines with some numbers. Usually a real supermarket, probably like ShopRite or Twins Faja or Jendor, when you go, there's a scanner that automatically reads the information through that barcode. The information read from that barcode goes directly to the system. It does not need too much processing. That is what we call direct. It means that the data is in a form suitable for processing without the need for data conversion. Then we have the punch card, paper tape system, magnetic media, optical media, voice input device like your microphone, imaging device like your scanner. So the magnetic, optical, voice and imaging device are direct data entry devices. So data entry implies that the transaction is recorded immediately in machine readable form. Immediately. This means that data is made available quickly for use. 1. 2. Fewer errors are made in data input since there is no manual data subscription. 3. Data integrity and accuracy are enhanced through the use of validation program in the system. 4. Data can be made available on a real-time basis or on a fast batch turnaround basis. So, magnetic devices. A. These are systems where data is converted to the machine readable form. Electronic pulses using magnetic properties. This system includes your keyboard. 1. Your keyboard contains alphabetic keys, numeric keys, punctuation keys, arithmetic keys, operation keys, 12 function keys F1 to F12, control keys, and some special symbol keys. You can pause this video, rewind if you have probably you have some things you need to understand immediately. Keyboard, your mouse, number 2. So let's talk about the output device. Sorry, we are still with optical device. The input device that use optical phenomenon includes optical character recognition, OCR, optical mark recognition, OMR, source data automation, light pen, touch screen. Let's just keep all this image input device. You can write that down. Let me scroll up to see. Okay, now computer output devices. Now a computer output device is basically any peripheral or hardware or component of a computer that enables you to output information. For instance, your computer speaker, loudspeaker, enables information to be outputted in form of sound and audio. Your printer, they are also output devices. Your monitor is an output device. So you can read this, write a note, but from the explanation I've made, you can also create a note out of it. Then the advantage and disadvantage of display equipment. You know, display equipment is your monitor, your computer screen that displays the information that is processed by the processor on your screen. So you learn the advantage of a display monitor and the disadvantages of it also. So you write those ones too down. So categories of output device: you have your monitor, which is called your visual display unit or your video display unit, or screen. That's your monitor. Visual display unit, screen resolution, screen presentation, screen shape. So you can, when we talk of screen resolution, this refers to the clarity of the image formed on the screen. The display device forms image from tiny dots called pixels. Note that, pixels, write that down also, that are arranged in a rectangular pattern. The more pixels available to display any image on the screen, the sharper the image is. More pixel implies higher resolution. Note that. Color presentation. The video display unit can be either monochrome, that's single color, or color. Monochrome display devices output in a single foreground color, that's white, black and white. The color screen includes your VGA, video graphic array, your CGA, color graphic array. Write all this down. EGA, enhanced color graphic adapter. MCGA, multicolor graphic adapter. SVGA, super video graphic adapter. You can write all these ones down. Also write this down. Color screen allows for better presentation for material because important items can be highlighted. Many display devices can produce both text and graphic outputs. Text output includes alphabetic characters, digits, and special characters, while graphic outputs include image such as drawing outputs and image maps. So, monitor shapes. Monitor are either in CRT. When you hear the word CRT, we mean cathode ray tube, or flat panel type. That's your flat screen. The CRT type uses a large tube type element that looks like a TV set. That's the olden days TV set. So we also have the flat screen, which uses liquid crystal display That's your LCD, liquid crystal display. So the major advantage of your flat screen is that, one, they are lightweight, they are compact, they provide better resolution, they are modern. So we talk about the graph plotter, which is an output printer mostly used by graphic artists and architects. A plotter is a peripheral device that is primarily used for the output of complicated fine graphic information. It's a printer though. In real life it's a printer, it's big printer. It is used mostly by architects, engineers, graphic artists. And from what you saw, the plotter is a peripheral device that is primarily used for the output of complicated fine graphic information. Computer output on microfilm. That's your COM. COM is used to store massive data on a compact form. It is often used for archival purpose. The output from the computer, which is alphanumeric or graphic, instead of being printed out, is displayed in a high-resolution cathode ray tube and then photographed into a very much reduced form that is a microfilm. The microfilm can be in form of a microfilm or microfiche. Just note this one and write it down the way I've explained it. So, advantages of the COM, I'll just mention two. Large volume of information can be condensed into a physical storage space. Information can be stored permanently for future use in a small space. You can write the other advantages down. And the disadvantages: the use of microfilm output device is restricted for the following reasons. Prohibitive price: it is highly expensive. There is restricted area to information since it is not readable to the naked eye. It requires highly trained, skilled personnel to handle. So we also have the printer, which is an output device, character printers, line printer, page printers. These are all output devices. You can write them down. You don't need to write them off or just list them out. We have the inkjet printer, that's your color printer, and thermal transfer printers, which are the ones that use toner cartridges to print. The central processing unit, the CPU. The CPU is the brain of the computer system. It is divided into two parts, namely the process and the primary memory. The computer processor, the processor and the primary memory. The processor consists of arithmetic logic unit, ALU, and the control unit The set of operation that the processor performs is known as the instruction, and this partly determines the processing speed. The arithmetic and logical unit is the part of the processor where arithmetic and logic operations are carried out. Let's move forward. That's the addition and subtraction, multiplication and division, exponentation. The logical operation include comparison, branch operation. A branch operation changes the order of the execution. Then number 3, movement of data. The control unit of the processor performs the following operation. 1. Receive instruction in a program, one at a time, from the main memory. Interpret the instruction. 2. Send out control signal to the peripheral device, particularly the internal and output devices. That's the input and output devices. That's what the control unit is in control. So you can write what I've explained down. You can rewind the video, pause it, write the explanation. You don't need to write the whole word. You only write what I've explained and what I've read. what I've not read, you don't need to write them down. Thank you. So let's continue. So data and instructions stored can be addressed as accessed very quickly, and hence it is referred to as immediate access storage, AIS, immediate access storage. Random access memory is your primary memory, which I've explained earlier on. Random, so I won't dive much into it. Read-only memory, let me just explain this. A memory is said to be read-only if information is permanently written and can only be read, such as a memory cannot be written to. ROM is non-volatile microprogram for input and output operation, and the booting program are kept in the ROM. So when you on your device, like your laptop or your phone, you see the phone will load, what we call loading, that is loading or is booting. Then now start seeing information. Probably it will display Nokia or iPhone. All these gymnastics comes up, and before the main window, the main home page of your device appears. All the information that is displaying on the screen during the loading process came from the ROM, read-only memory. Then we also have the PROM, the programmable read-only memory. This can be programmed by the user, unlike ROM. ROM, once it's in it, you cannot input or output. But in PROM, you can input and output programming into it. We have the erasable programming read-only memory. When data are recorded in EEPROM, they are just like ROM in behavior, but the content of the ROM can be changed by the use of an ultraviolet light, or revert all the cell to ones. Then new data and programs can be written in the chip. Another important memory is the cache memory. The cache. What is the cache? It is an high-speed memory capable of keeping up with processing speed of the processor. It acts as a buffer between the processor and the slower primary memory. External storage device, I've explained that you can just read through this and write your points, but they are your hard drive and your other storage devices. They are permanent storage devices. Magnetic storage device, your magnetic disk, that's your CD-ROM disk. Then let's go on. Winchester disk. In the Winchester disk, the head assembly in this disk is scaled in with the disk pack in order to alleviate the problem of crashing caused by dust particles. Winchester disks are non-exchangeable as they are in sealed units. And we have the floppy disk drive. For the old school guys, you understand, the cartridge disk. Magnetic tape. Just note the words. You don't need to write any notes on these ones I've just mentioned. The digital cassette tape, your old cassettes, if most of you are experienced enough to have met them. And we have the screaming tape, video tape recorder. Just write them down, but you don't need to write any chapter paragraph underneath it. Optical storage media. The optical storage media are divided into flash EEPROM and the optical disc. One, optical discs are similar to your compact disc audio system used in homes, the most common are the compact disk, read-only memory. Then 2, we have the CD-ROM disk, that's compact disk, read-only memory. Then we have WOM, write once, read many. Write once, read many. So WOM media allows data to be written onto them only once. The data cannot be changed. The data can only be read several times. That's all you need to know. Then we have the video disk. This is an optical disk that stores audio, video, text data. It can be accessed a frame at a time. Just write it is an optical disk that stores audio, video and text data. So let's go. Application controls. What are application controls? That's right. Application control are controls over the input, processing and output process. The one ensures that the input data is complete, accurate and valid. 2, ensures that internal processing produces the expected results. Number 3, ensures that the output reports are protected for disclosure. Input control. This includes input authorization, accuracy, batch control and balancing, error reporting and handling, batch integrity in online or database system. Input authorization. These are controls to ensure that data has been properly authorized to be input into the application system. Example includes username, password, signature on batch forms. Batch control and balancing. This involves controls put in place to ensure that total monetary amounts, total item, etc. are arithmetically correct. Error reporting and handling are controls to prevent erroneous error data being imputed into the computer system. Some of the input control techniques here include things like transaction log, reconciliation data, documentation, error correction procedures, transmitter log. Output control. Output control. The essence of output control is to ensure the following: that the information distributed get to the appropriate recipients. 2, that the information distributed is correct. 3, that there will be no change in the content and presentation of information between the point of process and output. In view of the above, some output control include sensitive reports must have specific printers which they can be printed from. There must be a controlled way of distributing reports. How long are the sensitive reports retained? You can write D, E and F also. So let's continue. Storage control. These are controls put in place at the database level where data is stored. This is to guarantee that data cannot be changed when resting on the table in a database. Example of storage control include file labeling in a particular order or preventing accidental loss of storage media, segregation of duty between input and storage officer. So you can write C, D and E also. So far we've been able to complete chapter 2. I'll treat chapter 3 in class and I'll send chapter 4 as a video next. then continue chapter 5 in class. If you have any question, just note it down, and you can ask me at any time, or send me a voice on my WhatsApp, and I will explain better. Okay, thank you and God bless.